Hello everyone. I will start with a brief presentation. First, let me introduce myself. My name is Volkan. I've been working in Prota Group for 12 years. And in this webinar today, we will talk about automated rebar layout for Corewalls and Polyline columns. So today, I would like to summarize our products, what we can do when we use, etc. Then I will continue with the live webinar, and at the end I will take your questions. So ProtaStructure is an all-in-one software that you can model, design, analysis, and you can obtain fabrication details. Also, RC reinforced concrete members details are available in the software. You can share your model with the other BIM platforms such as Autodesk Revit or SAF and IFC files because some of other softwares are using this kind of file formats. So ProtaStructure suite consists of 4 different softwares. First one is the primary one, ProtaStructure, that can that is able to do multi-material modeling, finite element analysis, and design. If you want, you can send this model to the ProtaDetails, and you can obtain RC detail drawings automatically. If you have a steel model, you can share your model with the ProtaSteel, and in here you can create your steel connections and you can obtain fabrication details. Lastly, with ProtaBIM, you can send your model to the Autodesk Revit environment, and with this model you can be part of the BIM environment. Okay, so let's see in action. Okay, I'm gonna create a model from scratch. So let's create a new model. Let's say our project code might be Corewall or Mergewall, whatever we want, we can insert in here. Of course, we prefer English characters. Then I'm gonna select the Polish template. Of course, we have provided different templates regarding to project habits. So in this case, I'm gonna select the Polish template. So in ProtaStructure, we have several ways to start in a project. First of all, if you want, you can create a project from scratch. You can create your grids, insert columns, walls, etc. Or you can prepare a grid system by orthogonal axis generator. You can use import functions, for example, IFC import, DXF import, or you can import members from the plan view, generally architectural drawing, I mean. So you can, with the external reference drawing, you can import axes, columns, shear walls, even beams and slabs. But generally, I just import axes, columns, and shear walls with this external reference drawing function. In this case, I'm going to start with the orthogonal axis generator. You can just pick a point as a grid intersection, and we can specify the axis spacings. Okay, so 3000 times 2 and 6000 millimeter. Okay, so our grid system has been generated automatically. If you want, you can insert a curved axis in here. So I will simply delete the existing one. Okay, we can just pick the grid intersections, then insert the curvature distance by F2 button. Okay, you may have different facades, so we can simply draw the this building edge with the actually multi-segment axis insertion option. Okay, just you can right click and finalize the axis generation just like this. Now I will continue with inserting columns. Okay, so once you click on the axis intersection, the relevant column will be generated just like this. If you want, you can use boxing around option. Okay, or in here you can see B1 and B2 values, which is column width and height. If you want, you can change the eccentricity values, or you can exchange the value of column width and height with this button, B1, B2 button. Okay. So what I'm going to do in here, I will align these columns on the curved axis by selecting the direction. Direction 1 represents X direction and direction 2 represents the Y direction. So I'm going to select the direction 2 and just box around all these axis intersections. Okay. Now we can continue with the different sections such as circular one. Okay. You can simply click on the axis intersections just like this. If you want, in our section database, we have several different polyline shapes. So I'm going to continue with the L shaped just like this. And we can just click on the grid system. If you want, you can use the cursor keys on your keyboard to place this column properly. Okay, so just like this. In here, I will just customize the rectangle column because we can transform any kind of column to the polyline column. For instance, we have a rectangle one. So what I'm going to do in here, I will transform this column to the polyline one. Let's say, let's just pass to the section edit, and we can add some corner points. Okay, and if you want, you can drag and drop to the desired coordinate just like this. Of course, if you want, you can just right click on it and you can specify this X and Y coordination manually, or you can simply drag and drop just like this. Okay. I will try to generate a symmetric one. Okay. So of course, if you want, you can arrange the grid spacing from here, or we have some settings for corner bar spacings or corner bar count. Okay. So once you click OK button, the relevant column will be actually the section of the relevant column will be updated just like this. Okay, so I'm going to use the same section over here. Now let's continue with the walls. Okay, you can simply draw these walls on the axis intersections. ProtaStructure is an axis-based software, so you should plan this axis insertions really carefully. Okay, if you want, you can merge these vertical members automatically. So if these shear walls are touching to actually these nodes are on the same segment, we are automatically merging these kind of shear walls. Or what we can do, you can simply select shear walls and you can just merge the selected ones just like this. Now I would like to continue with the beam members. So if you want, you can just box around and insert the beams, or you can just draw the beam members one by one. It's up to you. But generally, boxing around is, in my opinion, much more easier. So ProtaStructure is automatically detecting the shear wall. So the software is not inserting a beam on this shear wall, so there is no duplication as you see in here. Okay, let's just insert a couple beams just like this, and I'm gonna create a curved beam here. But before this, I would like to show that even the most complicated sections can be generated by the ProtaStructure. For example, let's just draw a really weird shaped column. If you want, of course, you can press the F2 button and you can specify the delta X and delta Y values. For example, 0, delta X 0, delta Y, let's say minus 900. And you can create a closed parameter just like this. And we can transform this parameter to the column just like this. Okay, so any kind of column can be inserted in the ProtaStructure interface. Okay, so let's just continue with the curved beam. Okay, again, I'm using the F2 button for curvature distance. In our case, it will be 1.5 meters. Okay, lastly, I would like to show about beams that we can insert a beam without access. So you can use intelligent points just like this, or you can use the F2 button and specify a distance just like this. So both options can be used by the users. Okay, I'm going to continue with the slabs. So I need to create, so before the slab insertion, I need to create the load cases and combinations. I haven't selected a seismic code, so you cannot specify the seismic loading in here for now. But if you select, for instance, Eurocode 8, it will be active. I can show this later. You can also select, for example, wind loading, soil pressure, or different load cases from here. Okay, so let's just click to beam region and the relevant slabs will be inserted just like this. Okay. If you'd like to insert the wall loads, you can use the loading tab, and for this purpose, generally we are using the load editor. In here, I'm going to use the wall load button. So you can simply select the wall load from our library. In my case, I'm going to use a 200 millimeter brick wall. If you want, you can add some openings from here. Okay. If you just box around the beams, it will be, all these walls will be automatically created. Let me open the 3D physical model, and you will see this partition wall loads. So now what I'm gonna do, I will just generate this story. I will just insert new stories. So let's say that we have a 3-story, and what we can do, we can generate this selected story information to the other stories. Just like this. If you want, you can delete some members on 3D view. For example, in my case, I'm going to delete the loads, okay, by using the delete loads command. You can also insert the slabs in 3D view. Okay. So what we can do, we can add, for example, actually we can edit the story information. Let's say that first two stories are 3.5 meters. Foundation depth might be 50 centimeter. This foundation depth is we only use this parameter for starter bars. Okay, so if you have, for instance, if you have 50 centimeter thickness rough foundation, you need to just write 500 millimeters, just like this. First story bottom level represents the top elevation of foundation. So in my case, minus 500 millimeter. Okay. So if you want, you can define similar stories. Okay. You can just select these stories, and once you define them as similar, okay, all adjustment will be applied to the other story. For instance, if I delete this column, it will be applied to the second story as well. Okay, so for instance, let's draw some cantilevers. So I'm gonna use the type 12, and in the cantilever part, you can specify the cantilever length. Let's say 800 millimeter. Of course, if you want, you can draw this cantilever. Actually, you can draw an edge for like complicated cantilevers, just like this. Maybe you can slightly different edges, just like this, or you can finalize if you want with the arc or with the line. It's up to you. Okay, and once you click to finish, as you see, the slab edge is ready. So we can simply insert a cantilever just like this. So, okay, due to the similar story definition, it's been copied to the second story as well. Normally, of course, you can insert your loads from here, like room or imposed loads from here. But generally, I prefer to change in a batch mode from slab table. Okay, you can simply select a column and modify. Let's say that we are using the room load. Okay, and you can simply select these options from here. So as you see, I changed all these slabs dead and live load at once. Okay, so let's save this model. Okay, now we can pass to the analysis part. So I'm gonna run the analysis. Before the analysis, I suggest you to use the finite element shell model for shear walls. And for slab model, if you want, you can include these slabs in the building model. Okay. So I'm gonna run this analysis just like this. Now it's creating the first stories mesh. Okay. So now let's just pass to the display analytical model part. As you see, we just created mesh elements on the first story. Okay. If you want, you can review this results from here, we have you can activate the diagrams. Use the, for example, envelope diagrams over here, or if you want, you can just select the specified load combination. Okay. Also, you can select the bending moments, and you can increase the scales if you want, just like this. Okay. So what I'm going to do now, I will pass to the design part. So let's go to the design, and let's talk about a bit settings. Okay. So in here we have some settings for the column design. Generally, I used fixed bar layout method because if you select bar layout optimization method, the software will not allow you to change the rebar numbers. So if you are using like me, because I generally change the rebar numbers and copying these rebar patterns to the other similar ones. You will see soon. You can also select the, for example, desired link types from here. Okay. Generally, I'm using for basement walls. Generally, I'm using the without end zones option, but for other stories, of course, if you are using Eurocode 8, you should create end zones in Shearwalls. So you can select them from here. So you can also limit rebar, actually rebar diameters from here. So we can simply select the column reinforcement minimum and maximum values from here. Okay. Sorry, let me close this Outlook. Okay. So of course, maximum column steel bar spacing and wall web steel bar spacing can be arranged by the user. If you want, you can insert concrete cover for columns and shear walls for all members. I mean columns and shear walls. You can update the links from here. And I'm gonna set the maximum link spacing as 200 millimeter, just like this. If you want, you can create support regions for links by selecting this option. But now we didn't select the Eurocode 8, so if you select the Eurocode 8, the support regions will be automatically generated regarding to the, of course, code. So let's select the all bars from here. As you see, we have increased the speed for columns, for column design, column and wall design. So you can see the design members in here. So I'm going to continue with the Polyline members. Okay. So of course, the software can create some default reinforcement pattern, but what we can do, we can use our own reinforcement design. So what we can do, we can add some corner bars, okay, or intermediate bars just like this. Okay, you just need to select the corner, then drag and drop to the, actually drag this point to the other corner. Again, I'm going to select this corner. I will keep pressing the left button of my mouse, and I'm going to select the second corner. Okay, it's really easy, as you see in here. Of course, if you want, you can generate these details automatically. So for this purpose, we can use the automatic containment. So what I'm going to do, I will use phi16 for all corner and intermediate bars. For N1 represents this, you can see in the figure. So I'm going to use 2 rebar for N1 segment. And for N4, I'm going to use again 2 rebar. Once you click OK, the software will automatically create the relevant reinforcements just like this. Of course, if we want, we can copy this information, reinforcement information, to the other similar sections. Okay, these green symbols shows that actually 2C9 and 3C9 have the same section, just like 1C9. Okay, let's paste bars to all. Okay, now this time I'm going to continue with the 1C10. Okay, again I'm going to use the rebar layout, and this time I will create this reinforcement from scratch. So let's just start with the link type. So I'm going to use closed link. Okay, we can also insert our corner bars. You just need to select the corner, click on the left button of your mouse and drag to the inside and leave your left button of your mouse just like this. Okay. Then what we can do, we can insert our intermediate bars. Again, I'm going to use the same method. Okay. Select the corner, press the left button, keep pressing and select the second corner. Okay. We can also add extra link if you want. You just need to draw this link from the center of the rebars. If you have a actually link edge just like this, we can add extra reinforcement in there. I'm gonna add one more in here. Sometimes you may want to select the okay. So of course, once you create these rebars, we can add our tie bars as well, just like this. So what I'm gonna do, I will copy this reinforcement to the other similar ones. As you see, 14 rebars has been copied to the other similar columns. And finally, we will insert the reinforcement in our merge shear wall. Okay. So of course, this kind of complicated shear wall geometries is the software cannot handle to insert these reinforcement with the default settings. So I'm gonna delete all steel bars and links. If you want to insert manually this reinforcement, you can use this method. For example, first I need to create my stirrups. For this purpose, we can use link type. For example, U-type link we can use in here. Then I'm going to create the end zones. Okay. We may use, for example, closed links. And these zone length ratio, generally 15-20% is sufficient. Okay. And you can see the zone length as almost 1 meter in here. I would like to use 8 rebars on the Y direction, so I'm going to insert 8. Okay, and once we click OK, it will be generate just like this. You can also insert the web rebars. Actually, I'm using the same method as in columns. Okay, now we can add our tie bars. Okay, so to insert a tie bar, I'm just selecting the rebar, center of rebar, and you can quickly create your tie bars just like this. Okay, of course we can create for the other segments, but I will use our automatic generation option. So once you click automatic containment, in here we have two options. If you want, you can generate the rebars with head zones, but first one, let's say that we don't have any head zone, so we can click on the reset bar counts, and the software will automatically determine the rebar numbers. Because we know that corner bar spacing in here, so it's using this 20 centimeter for the bar spacing, and if you want, we can add head zones as well. So for head zones, you need to mark this option. Okay, if you want, you can add, you can put bars for the short edge. You can add tie bars on the long direction here. Okay. Generally, you need to insert end zone rebar ratio, for example, 1% here. I would like to use Phi12 for intermediate bar diameter. Okay. So even this kind of complicated reinforcement can be generated in a couple seconds, just like this. Okay. So once you click OK, we can copy this reinforcement to the check the whether design status is sufficient or not. So we need to check this reinforcement with this option, check steel, don't select steel when previous bars are insufficient. Okay. Don't forget, if you are using copy and paste function, you need to check steel actually reinforcement of the members via this option. Okay, as you see, all polyline columns and merged shear walls are sufficient in this model. Okay, so let's just see our details in the ProtaDetails part. First, let's save this model. But before, you can clearly review this column reinforcement with the design status. Okay. Once you activated this design status function, you can clearly see that all columns are green. Okay. Of course, we haven't designed the beam reinforcement yet. For example, let me show you. Let's just design the beams as well, because I would like to show this design status, color-coded design status for beams as well. Okay, it's almost finished. Okay, so of course, if you want, you can list the failed members just like this. it's easy. And once you check the design status, the green ones are shown as the sufficient one. Generally, I suggest you to do this in 3D physical model. Let's use the design status. Okay. As you see, these curved ones are insufficient. Okay. So we can quickly realize that, for instance, the insufficient ones, or for example, green ones, which shows that they are fully sufficient in the design. So let's just pass to the ProtaDetails. I'm going to save this model. Of course, we can generate all drawings automatically, but in this webinar, I would like to just show the polyline and merge shearwall elevation details. So let's just start with the circular one, 1C8. Okay. As you see, we are preparing the details precisely. Let's add again L-shaped one. Also, as maybe you will remember that we have customized the section, so we are preparing the detail precisely. 1C11. Let's continue. Okay. Of course, if you want, you can draw the column details through the stories. It's also possible, just like this. So now I'm going to add a sheet for these members. A0 will be okay, in my opinion. Yeah. So let's pass to the shear wall. As you see, we have only a single merge shear wall. So I will just right click and select the draw shear wall elevation for single story. Of course, we can also obtain all these drawings automatically, but I'm just showing how you can create them one by one. So again, sheet, and we can create A0 just like this. Now I would like to insert count table. So we can simply select all these columns, right click, count table, and we can place this count table as we wish, just like this. All these reinforcements are intelligent. So once you, for instance, change this length, the relevant rebar will be updated. Actually, labels will be updated, and also quantity table will be updated instantly as well. Let's do this in here. So all these reinforcements are intelligent rebars. Okay. Let me show you. If you want, you can select this quant table and transform this table to the actually as Word and PDF format. Just like this. Of course, if it's needed, you can export this table to the Excel file. Okay. So just like this. So let's just save this project. I mean, save this drawings. and we can export them to the DWG file. Okay. For this purpose, we can double click on the export DWG. We can select the save drawing, and if you want, you can also change the DWG versions in here. Once you click on export, the relevant drawing will be exported to the DWG file. So let's finalize the presentation. So in our Prota Help Center, you can reach to our user guide, tutorial videos, reference manuals. Okay, from here. Now all users can reach this Help Center. Also, in our website, we have white papers and blogs, as seen in these figures. You can reach to our YouTube channel. We have plenty of different videos, also like tutorial videos as well. You can also subscribe our YouTube channel to receive the notifications for our new videos. Please follow us from our social media accounts for our webinars or for trainings in LinkedIn, YouTube, Facebook, Instagram. If you would like to purchase the software, you can reach to the our sales team via globalsales@software.com or www.protasoftware.com.